Number of integer solutions to the equation 2 power mod x into x square plus 1 equals 5x square. Nice question. First of all, we realize there is mod x here, there is x square here, there is x square here. If x equal to k works, x equal to minus k will work. If positive works, negative will work. If plus 2 works, minus 2 will work. If plus 11.3 works, minus 11.3 will work. Right? We can treat this as a quadratic in mod x or an equation in mod x. That way we can cancel everything merely. Understand that mod x, the whole square, is nothing but x square. So if we say mod x equal to y, 2 times y square plus 1 is 5y square. I can cancel a y. I can cancel a y keeping in mind that y could be 0. 0 works. And then we have, oopsie, 2y square plus 2 equals 5y. 2y square minus 5y plus 2 equal to 0. So 2y square minus 4y minus y plus 2 equal to 0. 2y into y minus 2 minus 1 into y minus 2 is 0. So y is half or 2. There's already a 0 that's possible. 0, half and 2, that works. This is y, which is mod x. So x could be plus or minus half, plus or minus 2 or 0. 5 different values are possible, but the question says number of integer solutions. Plus or minus half won't work. Minus 2 plus 2, 0. 3 different values. So 3 values of x work. The largest real value of a for which the equation modulus of x plus a plus modulus of x minus 1 equal to 2 has an infinite number of solutions for x. Nice simple question. And so we have x here and 1 here. This is modulus of x minus 1. Modulus of x minus 1 is nothing but the distance between x and 1. It has an infinite number of solutions. Modulus of x minus 1 plus modulus of x plus a equal to 2. You want to think about x plus a, this, as modulus of x minus a. And so it will have infinite solutions. So if minus a were here, x could be here, put x equal to 2. And so now think about it. When will it have infinite solution? First of all, between 1 and minus a, the distance should be not 5 or 15 or 20. It should be small. Right? Because this is modulus of x minus 1, this is modulus of x plus a. If minus a were 100, this distance itself is 99. It has infinite number of solutions. That gives us one beautiful getaway. It tells us that x should sit between 1 and minus a. We have 1 here, minus a here. This distance should be 2. X being anywhere here, this plus this will be 2. Or minus a could be here, this distance being 2. X being anywhere here, this distance plus this distance would be 2. And that is the kind of scenario we are looking for. And otherwise there will be a unique number of solutions, values for which it will work. And an infinite number of solutions. We are basically saying we should be able to say x can be anywhere between 1 and a, and this will work. Anywhere between 1 and a, it will work. The distance will be 2. That means x is bang in between 1 and a. And the distance between 1 and a is 2. Sorry, not 1 and a, 1 and minus a. Or minus a could be 3, minus a could be minus 1. A is 1 or a is minus 3. Both of these will be possible. So we are either thinking x lies between 1 and 3 or thinking x lies between minus 1 and 1. So a is minus 3 or a is 1. Largest real value is 1. Minus 3 is not available. 1 works. So we are basically looking at a to be 2 units from 1. The distance between x and 1 is given. If 1 and a were 2 units apart, then x can be anywhere in between. This will hold good. We'll have an infinite number of solutions. And so the more algebraic way of doing it, saying I denote the turning points as minus a and plus 1. We know that mod x equal to x if x is greater than or equal to 0, to minus x if x is less than 0. We're basically saying, I can say this x plus a plus x minus 1 equal to 2. That is one possibility, where this is positive, this is positive. Or minus x minus a minus x plus 1 equal to 2. That both are negative. Or x plus a plus 1 minus x equal to 2. Or minus x minus a plus x minus 1 equal to 2. You solve for this, we get 2x equal to 3 minus a. We get two solutions. We get minus 2x equal to 1 plus a. We get two solutions. You solve for this, a plus 1 equal to 2, a is 1. You solve for this, we get minus a equal to 3, a is minus 3. If a were 1, if a were minus 3, any x will hold good here. That's what we are solving for. Therefore, a could be 1 or minus 3, largest value is 1. That's the algebraic brute force way of solving it. And again, a beautiful method, but the longer method works better. The visual method works better. The number of distinct pairs of integers m, n satisfying this inequality. Wonderful, wonderful question. I really struggled with this one. So first thing to know is mod a less than mod b is same as saying a square less than b square. One implies the other. That's the first step to do. That means we can say 1 plus mn the whole square is less than m plus n the whole square. Or 1 square plus m square n square plus 2mn is less than m square plus n square plus 2mn. Nice, so far so good. This 2mn gets knocked off on both sides. 1 plus m square n square minus m square minus n square is less than 0. Or 1 minus n square minus m square plus m square n square is less than 0. 1 minus n square minus m square times 1 minus n square is less than 0. Or quite beautifully, 1 minus m square into 1 minus n square is less than 0. Nice. We're looking at distinct pair of integers. Product of two numbers is less than 0. Either this is negative, this is positive, or the other way around. Right? So either this is negative and this is positive, or this is positive and this is negative. The beauty of this is 1 minus m square is negative. That is reasonable. Lots of numbers. 1 minus n square is positive. 1 square is 1. N can't be 1. It will become 0. 2, 3, 4, 5, it won't work. Only possibility where 1 minus n square is positive is when n equal to 0. Only positive possibility where 1 minus m square is negative is when m is 0. So m equal to 0, n greater than 1 works. If m or n were 1, this won't work, it will become 0. If m is 0, n greater than 1 works. Or n equals 0, m greater than 1 works. Nothing else is possible. If m and n are both more than 1, both will become negative, product will become positive. If either of them is 1, product will go to 0. That doesn't work. So one of them should be 0, other one should be greater than 1. So m0, n greater than 1, or n0, m greater than 1. That's a possibility. Now let's come back to this question. This is not n greater than 1. This is mod n greater than 1, mod m greater than 1. Because we're talking about n square. So plus 1 works and minus 1 work. Plus 2 works and minus 2 will work. Plus and minus 1 will not work. Plus 2 and minus 2 will work. Modulus of m plus n less than 5. This is an interesting thing. So let's attack that. Modulus of m plus n less than 5. If m is 0, mod n less than 5. When m is 0, mod n less than 5, n has to be greater than 1, be 2, 3, 4. N could be plus or minus 2, plus or minus 3, plus or minus 4. Exact opposite. If you put n equal to 0, we have mod m less than 5. We know mod m has to be more than 1. M could be plus or minus 2, plus or minus 3 plus or minus 4. So 0, 2, 0, minus 2, 0, 3, 0, minus 3, 0, 4, 0, minus 4. 6 possibilities plus 6, 12 possibilities. Super tough question. Really tough question. So it's kind of question which says, okay, I'm not touching this. We square this, then we get somewhere. And still there's a couple of steps to go. And wonderfully tough question. 3x plus 2 mod y plus y. 3x plus 2 mod y plus y equal to 7. X plus mod x plus 3y equal to 1. We want to find x plus 2y. First I said, look, can I add these two equations and get x plus 2y? Can I subtract one from the other and get x plus 2y? Tough, because there's a mod y here and a mod x here. They're not going to go away in a hurry. Right? So what do we have to do? One beautiful thing. So very simple idea. Mod a equal to a if a is greater than 0 equal to minus a is less than 0 equal to 0 when a is 0. And so we can use that idea. Then when x is positive, mod x will be x. When x is negative, mod x will be minus x. You can form different equations, then solve them. So we'll have to solve for x positive, y negative, x negative, y positive, both positive, both negative. We'll get 4 sets of simultaneous equations, solve them, and then the solution we get should satisfy this criteria. If it does, then we have an answer. Then we can plug it. I have to solve the simultaneous equation 4 different variants. Now that is tricky. That's a pain in the neck. Maybe that's what they want us to do, which is fine, but then it's going to take time. One other thing that we can notice: x plus mod x, x plus mod x, x plus mod x. If we add x and mod x, it is going to be 0. X plus mod x will be 0 when x is negative. And so maybe there is something there. So what do? First of all, I'll put x as negative. That is these two. Because then this goes to 0. And then see where that takes me. So if x is negative, this goes to 0. 3y is 1. Y is 1 by 3. Y is 1 by 3, x is negative works. We are true. Let's go there to the first equation. 3x plus 2 mod y plus y is 7. Y is 1 by 3. So 3x plus 2y plus y is 3y. Y into 3 into 1 by 3 is 1, 7. 3x is 6, x is 2. This doesn't work. If you put x is negative, y is 1 by 3. If you put y is 1 by 3, I get x is 2. That doesn't work. So x is negative is not possible. Right? Now I have only 2 equations, both positive, both positive, x positive and y positive, x positive and y negative. Both positive, I'll have 3x plus 3y is 7 and 2x plus 3y is 1. I subtract 1 from the other, I'll get x is 6. If x is 6, 6 plus 6 is 12, 12 plus 3y is 1, 3y is minus 11, doesn't work. Y will have to be negative. X is positive, y is positive, does not yield any solution. X is negative, does not yield any solution. X positive, y negative. So we are looking for x positive, y negative. That is 3x minus 2y plus y is 7 and x plus 3y is 1. 3x minus y is 7. 2x plus 3y is 1. Multiply this by 3. 9x minus 3y is 21. Add these two. 11x is 22. X is 2. When we plug in x is 2, we should get y as negative. If we don't get y as negative, there is no solution. Done. Game over. When x is 2, let's plug this in. 2 plus 2 is 4 plus 3y is 1. 3y is minus 3, y is minus 1. 2 comma minus 1 works. Then x plus 2y. 2 plus 2 into minus 1. 2 minus 2 is 0. This works. There is perhaps some juicy solution sitting here somewhere, but I don't know. We have brute force it. We get the answer. We roll with it. For a real number, x, the condition, modulus of 3x minus 20 plus modulus of 3x minus 40 equal to 20. And wonderful. I'm going to first simplify this and say modulus of x minus 20 by 3 plus modulus of x minus 40 by 3 equal to 20 by 3. Divide by 3 throughout, make life simpler for ourselves. We're dealing with x. What are we going to do? We know that if you have 2 points P and Q, distance between them is modulus of P minus Q, which is nothing but modulus of Q minus P. Right? Or P and 9 is P and Q. Now we have 20 by 3 and 40 by 3. The distance between them should be 20 by 3. Let's think about this. I'm going to plonk 20 by 3 on the number line, 40 by 3 on the number line. Nice. Now x to this, x to that should add up to 20 by 3. This distance is 20 by 3. 40 by 3 minus 20 by 3. Or x has to be a point in between these two. If it is here, this distance plus this distance is 20 by 3. If it is here, this plus this will be way more than that. Our x is between 20 by 3 and 40 by 3. This is where x should lie. Right? So now let's come to the question. So 20 by 3 less than x less than 40 by 3. 6.67 less than x less than 13.33. Obviously that's not there in the choices. But the question says for a real number x necessarily holds if 6 less than x less than 11 won't work, because x by point x equal to 6.1, it won't work. 7 less than x less than 12, this could work. 10 less than x less than 15 won't work. X could be 14.2, it won't work. 9 less than x less than 14 won't work. X could be 13.9, it won't work. This is a subset of this. Therefore, that will work. Choice B for Bombay. This is a lovely question. Wonderfully challenging question. Let's look at this one. In how many ways can a pair of integers x comma a be chosen such that x square minus 2 mod x plus modulus of a minus 2 is equal to 0? Lovely question, because this can be framed as an equation in mod x. And so the wonderful idea. And so now think about this. So we have mod x square minus 2 mod x plus a positive number is equal to 0. The beauty here is mod x square minus 2 mod x plus 1 equal to 0 is a nice square of a quadratic expression. How do I say that? So mod x minus 1 whole square is x square minus 2 mod x plus 1. This can be equal to 0 when mod x is equal to 1, but this number cannot be more than 1. So straight away we know that this constant term, if it were more than 1, we have no solution. It is positive. If they are more than 1, we have no solution. We know we are talking about integers, or modulus of a minus 2. Modulus of a minus 2 can be 0 or it can be 1. Nothing else is possible. Fine. So I'm going to look at both possibilities. Let's say that's equal to 0. So now we have mod x the whole square minus 2 mod x is equal to 0. Mod x into mod x minus 2 equal to 0, or x could be 0, x could be 2, x could be minus 2. For all of these possibilities, a equal to 2 works. So there are 3 possible solutions here. X and a, 0, 2, 2, 2, minus 2, 2. 3 possibilities work. Now let's go to the other scenario where we say mod x minus 1 whole square is equal to 0. And so mod x minus 1 whole square is 0. This means mod x is 1. X could be 1 or minus 1. This is the scenario when modulus of a minus 2 is 1, or a is 3, or a is 1. A minus 2 is 1 or a minus 2 is minus 1. Both are possible. Now it could be x is 1, a is 3, x is 1, a is 1, or x is minus 1, a is 3, x is minus 1, a is 1.
4 possibilities exist. All 4 are possible. Here we have 3 possibilities, here we have 4, totally 7. Wonderful question, delightful question from the idea of completion of squares. We start off with that and then isolate that the constant term can only be 0 or 1. Plug in the constant term to be 0, find all possible solutions. Put the constant term to be 1 and find all possible solutions. Be rigorous. Remember, you're dealing with modulus of x. Remember, you're dealing with modulus of a minus 2. Find wonderful questions with the delightful 7 answers.
I got this one wrong. I got this one so wrong that it was embarrassing. Fine, so I'm going to do this. I'm going to say mod x into 6x square plus 1 is 5x square. We have mod x and x. Remember, mod x whole square is the same as x square. I'm going to say mod x equal to y. So call this as y. 6y square plus 1 equals 5y square. X square is mod x a whole square. So this way we can cancel a y. 6y square plus 1 is 5y. 6y square minus 5y plus 1 equal to 0. Number of solutions. Brilliant. We break this 6y square minus 5y plus 1. 6y square minus 3y minus 2y plus 1. So it is 3y into 2y minus 1 into 2y minus 1 is 0. 3y minus 1 into 2y minus 1 equals 0. Y is 1 by 3 or 1 by 2. Brilliant. Now y is mod x. So x could be 1 by 3 or minus 1 by 3, 1 by 2 or minus 1 by 2. All of these will work. So there are 4 values for this. Brilliant. Theta is 4 and I did this and I got a minus 1. Why? Because at step 1 we have cancelled this y. We're cancelling y on both sides. So y equal to 0 will work. Y is 0, x is 0. X is 0 is a trivial solution. You can look at this and say, put x equal to 0, both sides go to 0. So there are not 4 solutions, 5 solutions. Every time you cancel on both sides, you've got to keep in mind that you simply cannot cancel 0 on both sides. That means you cancel, you're saying this cannot be 0. So you have to worry about the time where it becomes 0 and then account for that solution. So x is 1 by 3 minus 1 by 3, 1 by 2 minus 1 by 2 and 0. 5 possible values exist.